Do you know that feeling, right? When you get something completely, but when you try to explain it, you just get that blank stare. We've all been there. Well, today, we are going to crack the code. We're going to figure out how to take really messy, complicated ideas and turn them into simple, beautiful explanations. Let's jump in. Okay, so this is our challenge for today. It's a page from a Korean math textbook. And whoa, just look at it for a second. It's a wall of information, right? You've got exponents, rational numbers, fractions, decimals. It's a lot. This is our mountain. This is what we have to make sense of. So, that's the big question, isn't it? How on earth do you take all this and boil it down to something simple and clear? Well, that's exactly what we're going to figure out together. When you're staring at a wall of information like this, your first thought is probably, okay, I need to explain everything. But here's a little secret. The first step to being a great teacher isn't about what you add, it's about what you take away. It's deciding what not to teach. See, the goal is not to translate every single formula and definition on that page. That would just be, well, more noise. Instead, we have to put on our detective hats. We need to search through all the clutter to find that one single golden idea, the one thing that makes everything else just click into place. So, after digging through everything on that page, we found it. We found the signal hiding in all that noise. Turns out there's one super useful fundamental rule buried in there that's, just perfect for a simple, clear lesson. And that golden idea is something called a terminating decimal. I know, it sounds a little complicated, but trust me, it's so simple. It just means a decimal that ends, it stops. For example, the fraction 1/2 is just 0.5. See, it has a clear endpoint. That's it. Simple, right? And here's the real magic, the clue that was hiding in the textbook all along. The secret, the key to the whole thing is hidden in just one place, the bottom number of the fraction. That's it, the denominator. So we've got our core idea, but you can't just shout out the rule, right? That's no fun. We need to build a little journey for the learner. We need a blueprint, a step-by-step guide to get them there. Let's take a look at what that plan could be. Here it is, our 3-step secret plan. Step 1, simplify. You always have to make the fraction as small as you can first. This is super important. Step 2, look down. We're going to completely ignore the top number. The secret's only on the bottom. And step 3, factor. We break down that bottom number into its prime factors, and that is where we find the hidden code. Now this is where the real magic happens. Just look at the difference. On the left, you've got the textbook language. When a non-integer rational number is expressed as an irreducible fraction. I mean, it's correct, but my brain hurts just reading it. Now look at our script on the right. If the only prime factors on the bottom are 2s and 5s, it means the exact same thing, but it's simple, it's clear, and anyone can understand it instantly. That is the art of simple. Okay, so we've found our idea, we've designed our lesson, and we've simplified our language. Now, let's see how it all comes together. Let's imagine you're a student, and this is the little explainer we made for you. Hello, everyone. Have you ever wondered why some fractions turn into decimals that stop and others just go on forever? Well, I'm going to show you a secret trick to figure it out, and there are only 3 simple steps. First, and this is the most important rule, always simplify the fraction first. Make it as small as you can. Second, you only have to look at the bottom number. That's it, just the bottom. And third, we're going to break that bottom number down into its prime factors. Remember, those are just the prime numbers that multiply together to make your number. Ready? Okay, here it is, the big secret. After you break down that bottom number, if the only prime factors you see are 2s and 5s, then you've got a terminating decimal. It's going to stop. But if you see any other prime factor in there, like a 3 or a 7, then that decimal is going to repeat forever. Let's try one. How about 7/8? So, step 1, can we simplify it? Nope, it's as simple as it gets. Step 2, look at the bottom number. It's an 8. Okay, step 3, what are the prime factors of 8? Well, that's 2 times 2 times 2. Now let's check our rule. Are the only prime factors 2s and 5s? Yep, it's all 2s. So that means 7/8 has to be a terminating decimal. And if we check on a calculator, what is 7 divided by 8? It's 0.875.
Look at that. It stops. The rule worked perfectly. How cool is that?
Okay, let's try one more. How about 5/6? Step 1. Is it simplified? Yes, it is. Step 2. Look at the bottom number. It's a 6. And step 3. Find the prime factors of 6. That's 2 times 3. Uh-oh. See that 3? That's not a 2 or a 5. So our rule says this decimal should repeat forever. And if you check it, 5 divided by 6 is 0.83333 on and on and on and on. It works.
And that's it. A simple, effective lesson. So why does this approach work so much better than just reading the textbook? Let's take a quick step back and look at the principles that make it so powerful.
Think of this as the recipe for a great explanation. First, you find just one core idea. Then you use simple, direct language. You build up the knowledge in clear, easy steps. You show examples that work and examples that don't. And maybe most importantly, you make the other person feel smart and capable. And here's the biggest takeaway. This really isn't just about math. This is a strategy for communicating, well, anything. A business plan, a science project, whatever. It's really about respecting the other person's time and attention. It's about being clear, not just being comprehensive. So the real lesson here isn't just about decimals. It's a whole new way to think and communicate. So I want to leave you with a question to think about. What complex topic will you simplify next?